Hello and welcome. This presentation will explore how to leverage Git in modern continuous integration and continuous delivery pipelines. We will explore how Git helps in automating the software development lifecycle. Git, a distributed version control system, lies at the heart of many automation workflows. We will also discuss continuous integration and continuous delivery, along with automation to better understand Git's role. Let's begin by understanding the fundamentals of continuous integration and continuous delivery, and then discuss Git's role. Continuous integration is the practice of merging code changes from multiple developers frequently, ideally, multiple times a day. Continuous delivery builds on top of continuous integration by automating the software release process. Continuous deployment takes it a step further by automatically deploying every change to production. By adopting these practices, you can reduce integration problems and improve the software quality. Git serves as the single source of truth for all code changes in a continuous integration and continuous delivery pipeline. Git commits and merges can trigger continuous integration and continuous delivery pipelines, initiating automated builds, tests, and deployments. Git also provides robust versioning and traceability, which are essential for managing changes and rolling back if needed. As an example, a simple git push command to a feature branch can trigger a continuous integration and continuous delivery pipeline, automatically building and testing the changes. Let's walk through a typical Git-based continuous integration and continuous delivery workflow. The first step is to develop new features or fix bugs in a dedicated feature branch. Next, the changes are committed and pushed to a remote repository. This push event triggers the continuous integration pipeline, where automated tests and builds are executed. After the tests pass and the code is reviewed via a pull request, the feature branch is merged into the main branch. Finally, the continuous delivery pipeline automatically deploys the changes to production or other environments. Here are some common Git commands used in this workflow. The git checkout b feature/login page command creates a new feature branch for developing a login page. The git commit m add login functionality command commits the changes with a descriptive message. The git push origin feature/login page command pushes the feature branch to the remote repository, triggering the continuous integration pipeline. Git offers several essential features that are crucial for continuous integration and continuous delivery pipelines. Git tagging allows you to mark specific points in the repository's history, which is useful for release management and versioning. Branching strategies such as Git flow and trunk-based development help manage code changes and collaborate effectively. Protected branches enforce code quality by requiring reviews and checks before merging. Pull or merge requests facilitate code reviews and discussions before integrating changes. Webhooks enable real-time notifications and trigger pipelines automatically on specific Git events. Here are some examples. The Git tag of version 1.2.3m, release version 1.2.3, command creates a semantic version tag. The git push origin v1.2.3 command pushes the tag to the remote repository. The git tag list command lists all the available tags. Additionally, webhooks can be configured in GitHub or GitLab repository settings by providing a URL, selecting relevant events like push and pull requests, and setting the content type to application or JSON. This allows the Git repository to automatically trigger continuous integration and continuous delivery pipelines on relevant events. Choosing the right branching strategy is essential for efficient continuous integration and continuous delivery. Here's a typical branching diagram that explains the different branching workflows. Let's discuss two popular branching strategies. Git flow uses multiple long-lived branches, such as main and develop, along with feature, release, and hotfix branches. This approach is well suited for scheduled release cycles, but can result in complex merge processes. Trunk-based development, on the other hand, relies on a single main branch or trunk and short-lived feature branches. This strategy is ideal for continuous deployment, enabling faster integration cycles and quicker releases. Choose a strategy that aligns with your team's workflow and release goals. Let's explore how Git hooks can enhance continuous integration and continuous delivery pipelines. Git hooks are scripts that run automatically on specific Git events, such as commits, pushes, and merges. These scripts are located in the .git/hooks directory of your repository. Git hooks can be classified as client-side and server-side hooks, depending on whether they run on the developer's local machine or on the remote server. Git hooks enable you to automate quality checks and enforce coding standards before code even reaches your continuous integration system. For instance, a pre-commit hook can run linters and unit tests to ensure that only high-quality code is committed. Here's an example of a pre-commit hook. This script first echoes a message, then runs linters using npm runLint and tests using npm test. If any of these commands fail, the commit is aborted to prevent bad code from being committed. Continuous integration configuration can be stored directly in your Git repository, enabling version control of your pipeline definitions. Here's an example of a GitHub Actions workflow defined in a YAML file. This workflow is triggered on push events to the main and develop branches, as well as on pull requests to the main branch. The workflow defines a build job that runs on Ubuntu, checks out the code, and performs other continuous integration steps. Here's an example of a GitLab continuous integration and continuous delivery pipeline defined in a YAML file. This pipeline defines stages such as build, test, and deploy. The build stage installs dependencies and builds the application, and is triggered only on the main branch and merge requests. The GitLab continuous integration and continuous delivery pipeline supports branch-specific configurations, which enables you to define different pipelines for different branches. Pipeline history is tracked alongside the code in Git, providing full traceability and auditing capabilities. To optimize your Git workflow for continuous integration and continuous delivery, consider these best practices. Always protect your main branch by requiring code reviews and passing continuous integration checks before merging. Implement semantic versioning using Git tags with the major.minor.patch format for clear release tracking. Follow a structured commit message format like conventional commits to automate versioning and changelog generation. Keep your repository clean by using .gitignore to exclude build artifacts, dependencies, and environment-specific files. Use shallow clones in continuous integration pipelines with git clone, depth equals 1 to speed up the checkout process. Finally, use Git large file storage, also known as Git LFS, for storing large files outside the main repository to keep Git operations fast. For complex projects, Git submodules and monorepos can be valuable. Git submodules allow you to manage projects with multiple repositories as a single unit. Monorepo tools help manage large code bases within a single repository. Some popular tools for managing monorepos are Lerna and NX. Git sparse checkout lets you check out only specific directories to speed up continuous integration. This is particularly useful for microservices architectures, where you may only need to build and test specific services. Sparse checkout can be initialized using Git sparse checkout init, cone, and directories can be specified using Git sparse checkout set frontend/src config. Conditional continuous integration, based on changed paths, allows you to trigger specific continuous integration jobs only when relevant files have been modified. This can be achieved by checking if specific files have changed using git diff and grep commands. In summary, Git is the foundation of modern continuous integration and continuous delivery pipelines, enabling automation, version control, and collaboration. Choosing the right branching strategy and leveraging Git hooks can further improve your workflow. Storing continuous integration and continuous delivery configurations in Git ensures traceability and reproducibility. Here are some resources to help you continue your Git continuous integration and continuous delivery journey. Read the Pro Git book by Scott Chacon for a comprehensive understanding of Git. Refer to the GitHub Actions and GitLab continuous integration and continuous delivery documentation for detailed information on configuring continuous integration and continuous delivery pipelines. Finally, check out the Atlassian Git tutorials for practical guidance on using Git effectively. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.